Welcome everyone to the solving of Edexcel IAL-S1 May 2025 prediction ideas. We will be going through each of the questions with concise explanations to help you understand each and every question with details. Now remember, this is just an idea of what may come in the 2025 examination paper. It is not the actual paper, of course. But there's a high probability that the concepts covered in this prediction will be assessed in the May 2025 exam session. So without wasting any more time, let's begin. So in the first question, Rajesh is preparing for a driving license test, which he can attempt up to 3 times if he fails. If he passes the test, he will obtain his license. The probability of passing the test on the first attempt is 70%. However, with each subsequent attempt, the probability of passing decreases by 15%. Complete the tree diagram below to show this information. So this is the first attempt. So for passing on the first attempt, the probability is 70%, which is 0.7. So this will be 0.3 because 1 minus 0.7 is 0.3. However, with each subsequent attempt, the probability of passing decreases by 15%. So in this part, this will be 70% minus 15%, which is equals to around 55% or 0.55. So automatically, this will be 0.45. And for the next part, it will be 55 minus 15%, which is equals to 40% or 0.4. So this will be 0.6. Now in the last part, we know that with each attempt, the probability of passing decreases by 15%. So this will be 40% minus 15%, which is 25% or 0.25. So the other one will be 0.75. So that is it for the first part of the question. Now moving on to the next part of the question, given that the probability of Rajesh obtaining his driving license is 93.9%, find the probability that he passed on the first or second attempt. So this event already occurred. Now we need to find another event occurring, which is that he passed on the first or second attempt. So let's first find out the probability that he passed on the first or second attempt. So the probability will be, if he passes on the first attempt, it will be 0.7. And if he passes on the second attempt, it will be 0.3 times 0.55. So it's 0.3 times 0.55. Now you need to add the two probabilities together. So this is equals to around 0.865. Now what they have told us to find is that the probability of Rajesh obtaining his driving license is 93.9%, which means that this event has already occurred. So it's the probability of passing. Now we need to find the probability that he passed on the first or second attempt. So it's either first or second attempt. So we basically need to find this value. So in order to find this value, in the denominator, there will be the probability of obtaining the driving license, which is 0.939, and in the numerator, there will be the probability of passing on the first or second attempt, which is 0.865. So this will be equals to around 0.921. So that is the answer for this part of the question. Now moving on to the second question of the paper. Ahmed works for a car insurance company. He randomly selects 8 drivers and records the cost of their car insurance and the number of years Y. since they first obtained their driving license. The data are presented in the table below. So they have given us a table and some variables, some value of some variables. Now in the first part, we need to draw a scatter diagram for these data. So it's very easy. So in the x-axis, there needs to be the variable t, and the y-axis, there needs to be the variable c. So the scatter diagram looks something like this. And from this scatter diagram, we can see that it's a negative correlation. So in the second part, we need to comment on the relationship between C and T. So it's basically negative correlation. So it's negative correlation. Now moving on to the third part of the question, we need to find the equation of the regression line of C on T. So first of all, the equation of the regression line should look something like this. P equals A plus B times T. Now, the question is that why is it P? It could be in terms of C and T only. Now, in the variables they have given us, you can see that we know the values of the mean of T. I mean, two variables are related to all of these values. One is P and the other one is T. So that's why you need to write it as P equals A plus BT. Now, first of all, let's find out the value of B. So we know that the value of B can be written as summary statistic of TP divided by summary statistic of double P. So the values are given as negative 3,415. So that's negative 3,415. And the summary statistic of double P is given as 86,500. So overall, this will give us a value of negative 0.0395. So this is the value of P. Now we need to find out the value of the constant A. Now if we look at the equation and make A the subject, we will get A equals P minus BT. Now in order to get the value of A, you just need to substitute the values of mean of P and the mean of T into the equation instead of writing as P and T only. So this is how you get the value for A. So the mean value for P is 665, and the value of B is negative 0.0395, and the mean value of T is 17.13. So overall, this should give us a value of 665 or 665.7. So this is the value of A. So the equation of the regression line should look something like this. P equals 665.7 minus 0.0395t. So this is the equation of the regression line. Now moving on to the next question, we need to use our regression equation to estimate the price of car insurance for Omar, who obtained his driving license 19 years ago. So in this part, we just need to substitute the value of t equals 19 into the equation of the regression line to estimate the value of P, which is the price of the car. So when t is equals to 19, the price is 665.7 minus 0.0395 times 19. So the price is equals to around 665 euros. So that is the answer for part D. Now moving on to the next part of the question is that Ibrahim obtained his driving license 30 years ago and decides to use Ahmed's data to predict the price of his car insurance. Comment on Ibrahim's decision, provide a reason for your answer. Now as you can see that the value of t is 30 in this part, but from the data given, 30 is outside the range of this data. So Ibrahim's decision is actually not a good decision, as 30 years is outside the range of our data. So the answer to this part will be, so it's not a good decision, as 30 years is outside the range of data. So that is it for the second question. Now recalling back to the second question, there was a slight mistake in finding the value of b. So the value of b, I have written the formula as summary statistic of TP divided by the summary statistic of double P. This will be actually double T. So the summary statistic of double T is 188.88. So this is equals to around negative 18.1. So now if we change the values, so it's negative 18.1. So the value of A will change. So the value of A is 975. So the equation of the regression line is 975 minus 18.1 and t. Now from the part D, the value of t is 19. So the value of p will be 975 minus 18.1 times 19, which is equals to around 631.1 euros. So that is it for this part. Now moving on to the next part of the question, the third part of the question paper. The table below shows the average cost of salmon per kilogram, which is S. And it also shows the price of lobster, which is L, both in dollars for 8 different years. So the table is given for S and L. Now you may use summary statistic of double S and summary statistic of double L. Now in the first question, we need to find the exact value of summation of SL. So it's quite easy, because summation of SL, it's basically you need to multiply the individual values and we need to add the values. So summation of SL will be 20 times 80 plus 23 times 75 plus and so on up to 43 times 50. So the summation of SL will be 15,585. So that is the answer to part 1. Now moving on to the next part, which is we need to find the summary statistic of SL. So if we use the formula, it will be summation of SL minus summation of S times summation of L divided by N. So the summation of SL is 15,585. So that's 15,585. And summation of S, we do not know the summation of S, but we can find out the value. So the summation of S is all of these values added together. So this will be 254. Now we need to find out the value of summation of L. Now if we add up all of these values, we should get an answer of 512. Now we can substitute each of the values, so that the summation of L is 254 and the summation of L is 512. And the value of N is basically the number of data set So we have 1, 2, 3, 4, 5, 6, 7, 8, 8 data sets. So 8 is the frequency, which is the value of n. So this will be equals to negative 671. So this is the summary statistic of SL. Now we need to calculate the product moment correlation coefficient between S and L. So now we can use the formula, which is summary statistic of SL divided by root over summary statistic of double S and summary statistic of double L. So this is negative 671, and in the numerator this is equals to 507.5 multiplied by 894. So this is equals to negative 0.9962. So that is the answer for this part. Now we need to, in the next part, we need to interpret the value of the correlation coefficient. So we know that the correlation coefficient will be negative, which means that if the price of salmon increases, the price of lobster will decrease. Now it's a negative correlation because the value of R is negative. So in part D, you just need to give an interpretation. So the interpretation is if price of salmon increases, price of lobster will decrease. So that is it for this part. Now in the next part, a ninth year is added to the dataset. In this year, the average cost of salmon per kilogram is 36 and the price of lobster is $63. Without further calculation, state whether the value of the product moment correlation coefficient will increase, decrease, or stay the same when all 9 years are used. Give a reason for your answer. So as you can see, the value, if the salmon decreases, the lobster will increase. So as you can see, in the 8th year, which is this one, the 8th year, the difference is not much. The difference is only 7. But in the 9th year, the difference is almost twice. So the difference is 30, which means that the value of the product moment correlation coefficient will increase. So PMCC will increase. Because the difference of the 9th year is twice the difference of the 8th year. So that is the answer for this part, and that is it for this question. And moving on to the fourth part of the question, a research team is studying the number of hours of overtime worked by 225 employees in a public health organization over a month. The histogram below represents the results. Now in the first question, we need to calculate the number of employees who have worked more than 35 hours of overtime in the month. So we need to calculate this area. Alright. Now in order to calculate this area, we do not know the scaling of the y-axis, which is the frequency density axis. So we need to find out the value of the scaling. Now if we want to find out the value of the scaling, we can take that each of the square is represented by the by a constant value, which we do not know. Let's call that constant value k. So the height of this will be, so this is 7.5k, and this will be 30k. So this is 30k. So this is 30k, and this will be 22.5k. This is 22.5k, and this is 7.5k. And the final one, it's around 42.5. Wait. So this is not 42. This is actually 15k. Okay. So the frequency of this bar will be 7.5k times 15. So 7.5 times 15. So this is 112.5k. And the next one is 30 times 10, which is 300k. And the third one is 22.5 times 5, which is 112.5k. So this is 112.5k. And the next one is 7.5 times 5, which is 37.5k. And the final one is 75k. Now, if you add up all of the values, that is 112.5k, 112.5k, and the other one is 300k. So it's 300k, and that's 112.5 and 37.5. And the last one is 75k. So these values actually represent the number of people, which is the frequency. And we know that the total number of people is 225. So from this, we can find out the value of k. So the value of k is 6 over 17. Now we just need to find the number of employees who have worked more than 35 hours of overtime in the month, which means that we just need to add two of these values. So it's basically 37.5k, 6 over 17, plus 75k. Okay, so there was a slight problem, is that 7.5 times 5 is actually 37.5. So it's 37.5. So this will be 37.5, and now the whole value of k will change. So the value of k is actually 2 over 5. So this is 2 over 5, and this will be 2 over 5 also. So finally we get an answer of 45 employees. So that is the answer for the first part. Now for the second part, we need to estimate the mean number of hours to the nearest hour of overtime worked by these employees in the month. So in order to calculate the mean value, we need to take the midpoint of the class. So in this case, the midpoint of this class is 12.5, and the midpoint of this class is 25. And the midpoint of this class will be 32.5. And the midpoint of this class will be 37.5. And the last one will be 42.5. You need to take the midpoint and multiply it by the frequency. The frequency are 300k, 37.5k. So let's first write these in numerical values. These are in terms of k. So 300k can be written as 125. So this is 125. And 37.5k can be written as 50. So this is 15. and 112.5k can be written as 45, and 37.5k is actually 15, and 75k is 30. Okay. So the estimated mean will be, wait, so that's part B. So the estimated mean, so it will be 12.5 times 15, 12.5 times 15 plus 125 times 25, 125 times 25 plus 45 times 32.5, 45 times 32.5 and 15 times 37.5. It's 15 times 37.5, and the last one is 30 times 42.5. And we need to divide this whole value by the total frequency. The total frequency is actually 225. So it's 225. So now we can find out the mean value. So the estimated mean will be around 29 hours. So that is the answer for this part. Now moving on to the next question, we need to estimate to the nearest hour the median number of hours of overtime worked by these employees in the month. So we need to find out the median position. So there are a total of 225 employees. We need to divide it by 2. We get 112.5 employees. It's around 113, but you can take the exact value when you're using linear interpolation. In this case, we need to use linear interpolation. So 112.5 actually lies in this class. So if you draw the diagram should look something like this. Let's assume that this is the median, which is Q2, which is the number of hours worked. And the upper boundary of this class is 30 and the lower boundary is 20. So the upper boundary is 20, the lower boundary is 20 and the upper boundary is 30. And the frequency of the median is 112.5, and the cumulative frequency of the upper class will be 15 plus 125. So it's 15 plus 125, which is 140. And we also need to find out the cumulative frequency of the lower class. I mean the class before that, or in this class, of course. So the cumulative frequency in the first part of the class will be 15. So this is actually 15. So the value of Q2 can be written as 20 plus 10 divided by, it's not 10, wait, okay, plus 10 divided by 140 minus 15, that is 125. Okay, sorry. So let me just rewrite this. This can be written as Q2 minus 20 divided by 30 minus 20 is equals to 112.5 minus 15 divided by 140 minus 15. So from this we can find out the value of Q2. So the median number of hours worked is 27.8 hours. So that is the answer for part C. Now moving on to the last part of the question, is that the research team wants to compare these data. with overtime data collected from the previous month to evaluate whether overtime hours have increased. State, giving a reason, whether the research team should use the median or the mean to compare the overtime hours. So as you can see from the bar graph, you can clearly see that the data is skewed. We do not need to know whether it's positively skewed or negatively skewed. If the data is skewed, we always need to use the median to compare the data. So in this case, as the data is skewed, median must be used. So that is it for this part. Now moving on to the next question. 100 people are surveyed about their interest in three activities: hiking, swimming, and cycling. So first of all, instead of looking at this information, the first question is about that we need to draw a Venn diagram to represent this information. So let's draw the Venn diagram. So the base template of the Venn diagram should look something like this. H is for hiking, S is for swimming, and C is for cycling. Now, everyone who enjoys hiking also enjoys swimming. So this is the first information. No one enjoys both swimming and cycling. So swimming and cycling, no one enjoys both of that. Okay, so now 80 people do not enjoy cycling, and 15 people who enjoy swimming but do not enjoy hiking. Swimming and hiking, okay. So let's work with the first information. Everyone who enjoys hiking also enjoys swimming. Now we do not have an exact value for this, but if we look at the second information, that's no one enjoys both swimming and cycling, which means swimming and cycling, in this region it will be 0, and in this region it will be 0 also. Now 80 people do not enjoy cycling. 80 people, so instead of working with that information, let's work with this information. 15 people enjoy swimming but do not enjoy hiking. Enjoy swimming but do not enjoy hiking. Now 35 people enjoy hiking, which means that those who enjoys hiking also enjoys swimming. So which means this 35, it will be in this part. So this will be 0. Now 15 people enjoy swimming but do not enjoy hiking. So 15 will be in this region. 80 people do not enjoy cycling. So 80 people do not enjoy cycling. Okay. Now, if we use this information, it's that 80 people do not enjoy cycling, which means that C prime is 80. So the region included in C prime is this region, and this region. Now, if I subtract 35 and 15 from 80, I will get the value of this region. So it will be 80 minus 35 minus 15, which is 30. So this is 30. And we know that there are a total of 100 people. So if I subtract everything from 100, I will get the value of this region. So 100 minus 30 minus 35 and 50. So this region is 20. So that is it for this Venn diagram. Now moving on to the next question. We need to identify two activities from the survey that are mutually exclusive. Find the probability that, oh, okay, so that is the next question. So we need to identify two activities from the survey that are mutually exclusive. All right. So we know that, so the answer can be two parts. Now we need to identify two activities from the survey that are mutually exclusive. Now as you can see that H and C are mutually exclusive. Also C and S are mutually exclusive. But uh, the mark to the question is only 1 mark, so you can give either one of the answers. So you can say that the first option is that H and C are mutually exclusive, and the second option is C and S are mutually exclusive. So that is the answer for this part. Now moving on to the next part, we need to find the probability that a randomly selected person does not enjoy hiking, swimming, or cycling. So this randomly selected individual does not enjoy any of the activities. So the probability will be, so they're talking about this region, which means that the required probability is 30 over the total outcomes, which is 100. So it's basically 3 over 10. So that is it for this part. Now we need to find the probability that a randomly selected person enjoys swimming. So in the swimming section, the total number of people are 35 and 15. So if we add these two values, we should get 50. So the total probability would be 50 over 100, which is 1 over 2. Now, in the next part, they have said that we need to find the probability that a randomly selected person enjoys hiking or cycling. So hiking or cycling. So it's either this or this. So the required outcome is 35 plus 20. So we can say that the required outcome is 35 plus 20, which is 55. And the total outcome is 100. So overall, this is 11 over 20. Now moving on to the next part, given that a randomly chosen person enjoys swimming. So they have chosen a person from the swimming section. So it's basically this section. Find the probability that they also enjoy hiking. So the required outcome is 35 and the total outcome is 50. So overall, the probability will be 35 over 50, which is 7 over 10. So that is it for this question, and see you in the next video. Now moving on to question 6. The discrete random variable x has the following probability distribution. So the probability distribution table is given where A, B, and C are probabilities. Given that expected mean of x is equals to 0.8 and Ex squared is 1.3. Now first of all, we need to find out the value of C and also the value of A and B. Now we know that the expected value of x can be written as the x multiplied by the probability, adding up all of the values together, which is -1 times A plus 0 times B and plus 1 times A and 2 times C. and this is equals to 0.8. So that's minus a, and this is 0. That's plus a, and this is 2c. So these two cancels out. So the value of c is 0.4. So that is the value of c. Now moving on to the next part, we need to use the other information. It's that ex squared is equals to 1.3. Now in order to write ex squared, we can write ex squared as the summation of x squared times the probability. So it's basically minus 1 squared times probability, and 0 squared times b, which is 0, and 1 squared times a, plus 2 squared times c, and this is equals to 1.3. So it's a plus c. And we know that the value of c is 0.4. So from this we can find out the value of a. So the value of a is negative 0.3. Now there seems to be an error in the question. Is that the probability of minus 1 is a, but we know that a cannot be negative because the probability cannot be negative. So for the sake of the question, let's just assume that the value of a is positive. So let's assume that the value of a is positive. So the value of a is 0.3. So this is 0.3, this is 0.3, and the value of c is 0.4. And if we add up all of the probabilities, we get 1. And if we subtract 1 from 1, we get the value of b, which is 0. So this is 0. Okay. Now for the next part, we need to find out the variance of x. The random variable y equals 5 minus 3x. Find ey. Okay. Okay, so this is the next part of the question. First of all, we need to find out the variance of x. We know that the variance of x can be written as ex squared minus ex whole squared. So it's basically 1.3 minus 0.8 squared. So this is 0.66. Now the random variable y can be written as 5 minus 3x. Find expected value of y. So we know that we can replace y with 5 minus 3x. And this can be written as 5 minus 3 times ex using the formula we have learned before. So the value of ex is 0.8. So this is equals to 2.6. So that is the answer for this one. Now moving on to the next part, we need to calculate the variance of y. So again, y can be written as 5 minus 3x, and this can be written as 3 squared times variance of x, again using the formula from before. So it's basically 9 times variance of x, and variance of x is 0.66. So this is equals to 5.94. Okay. Now we need to find the probability that y is greater than or equal to 0. So y is greater than or equal to 0. Let's first solve this inequality first. So that's 5 minus 3x is greater than or equal to 0. So x is less than or equal to 5 by 3. And 5 by 3 can be written as 1.67. So x is less than or equal to 1.67. We need to find the probability of x is less than or equal to 1.67. So when x is less than 1.67, these are all the values that I can see. So we need to add up all of these probabilities to get the final answer. So it's 0.3 plus 0 and plus 0.3, which is 0.6. So that is the answer for this part, and I'll see you in the next question. Now moving on to the last question of the paper. A coffee machine fills cups with coffee. The volume of coffee delivered by the machine to a cup is x milliliters, where x is normally distributed across the mean and variance. So they have given us the value of mean and the variance, the standard deviation. So we can say that x is normally distributed across 505 and 1.8 squared. So first of all, we need to find out the value of the probability for x to be greater than 507. So probability x is greater than 507. This can be written as 1 minus probability x is less than 507. And we need to convert this value of x into z. So we can write this as z is less than 507 minus the mean value, which is 505, divided by the standard deviation. And we converted this to z using this formula. It's that z equals x minus mean over standard deviation. So this is equals to around 1.11. So that's 1.11. So when the value of z is 1.11, the value of phi z, or the probability, is 0.8655. So that's 0.86, oh, 8665. Okay. So this is equals to around 0.8665. So it's 0.1335. So that is the answer for this one. Now moving on to the next part, we need to find the probability for x to be greater than 501 but less than 505. Now we can write this as, wait, let me just show you. We can write this as probability of x to be less than 505 minus probability for x to be less than 501 using the help of the bell curve. And then we need to convert these values of x into z. So we can write this as z minus 505 minus 505 divided by the standard deviation. So overall this will give us a value of 0 minus, and then let's convert this value of x into z. So it's 501 minus 505 divided by 1.8. So this gives us a value of negative 2.22. Now, since the value of z cannot be negative, we can write this as 1 minus probability z is less than 2.22. If you're confused about this formula, you can check my video on the normal distribution. That will help you give you a clear understanding of the formulas. Okay, so since there is a minus sign at the front, this will be -1 and plus probability this. Okay, so when the value of z is 0, the value of phi z is 0.5. And when the value of z is 2.22, the value of phi z is 0.9868. So this is equals to 0.4868. So that is it for this part. Now moving on to the next part, following adjustments to the machine is made. The mean volume of coffee delivered to each cup is 503 milliliters with a standard deviation of 1.6. So now the value of x will change. I mean, x will be normally distributed across 503 and 1.6 squared. Find W such that the probability of 1006 minus W is greater than x is less than W. Okay, so the probability of this is given. All right. So 1006 minus W. All right. So we need to use the help of a bell curve. So let's assume that the bell curve looks like this. So it will look something like this. And this is the mean value, where this is 503. And let's assume that this is the point where the W exists. So 1006 minus W will exist in this part. So this is 1006 minus W. Now the probability of this region is 0.9426. If I subtract it from 1, I will get the probability for 0.26. So that's 0.0574. I will get the probability for these two regions. And due to the symmetry of the normal distribution curve, if we divide it by 2, it will give us a value of 0. Wait, 0.0287. So it gives us the area of one of these regions. So let's say that I want to take this region, I want to work with this region. So I can say that the probability for x to be greater than W is 0.0287. Now I can write this as 1 minus probability x is less than W. So let's convert this value of x into z. So this can be written as z is less than W minus the mean. The mean value was 503. Yep, it was 503. And the standard deviation is 1.6. So the overall probability will be 503 over 1.6. So the overall probability is 0.9713. So when the probability is 0.9713, the value of z is 1.9. You can look it up in the statistical table. So you can say that W minus 503 over 1.6 is 1.9. So the value of W is about 1.9 times 1.6 plus 503. So it's around 506.04. So this is the value of W. So that is it for this part. Now moving on to the next question. The coffee machine is then further adjusted, and now the mean volume of coffee per cup is mu equals r and the standard deviation is q. So now the x is normally distributed across r and q squared. And they have given us two information that the probability for x to be less than 499 is 0.01. All right. So we know that the probability for x to be less than 499 is 0.01. Now let's convert this value of x into z. So probability z is less than 499 minus the mean, which is R, divided by the standard deviation, which is Q, is equals to 0.01. And now, as you can see, that the probability is 0.01, which is less than 0.5. That's why we need to subtract 1 from it. So it will give us an answer of negative 0.99. So when the probability is negative 0.99, if you just ignore the negative sign, the value of Z is 2.32. So I can say that 499 minus R divided by Q is equals to 2.32. Now there's a negative sign at the front, so there will be a negative sign in this part. So from this, we will get an equation which looks something like this. So this is our first equation. Now let's move on to the second equation. Is that the probability for x to be greater than 505 is 0.05. And we know that the probability for x to be greater than 505 is 0.05. Now let's convert this inequality sign into a less than sign. So it's 1 minus probability x is less than 505 is equals to 0.05. Now let's convert this value of x into z. So that's z minus 505 minus the mean value, which is r, divided by the standard deviation, which is q. So overall, the probability will be 505 minus r divided by q. So this is equals to about 0.95. So when the value of phi z is 0.95, the value of z is 1.64. So we can say that 505 minus r over q is 1.64. So finally, we will get an equation which looks something like this. Now, since we have two equations, if we solve these two equations simultaneously, we will get the value of r and q. So the value of r is around 502.5 and the value of q is about 1.52, or you can just leave it as 1.5. So that is it for this question. This was the last question of the paper, and I hope you guys enjoyed the video so far. Don't forget to comment, like, share, and subscribe. And I'll see you guys in the next video.